Okay. I want to welcome everybody to Hci for August of 2022, and our guest speaker tonight is Andrew Head. And before I introduce Andrew from University of Pennsylvania, let me tell you a couple of things about Hci that many of you already know. And let's see if I can do that slideshow one more time. Yeah. So we're going to hear from Andrew about interactive authoring and reading. And I noticed people, as I was reminding Andrew, I guess not reminding myself and telling Andrew for the first time, about a quarter of the Hci audience is new here for the first time, and about 50% generally are people who come from time to time when the topic interests them, and about a quarter are people like me, where we just keep coming every month no matter what. Some things about Hci. We are the local chapter of the Association for Computing Machinery's special interest group on computer-human interaction, or as we like to say now, human-computer interaction. Membership in Hci is $20 a year, very inexpensive, really helps us. And we have lots of these little bulleted items. Currently, there's one active Birds of a Feather group. On the fourth Tuesday, there's a Careers in Chi, and Edwin can tell you more about that. And I think you can all see Edwin somewhere on your screen. You want to say something about that, Edwin?
Hopefully my microphone is working well enough, but maybe not.
No, that's good. Better.
All right. So we just basically, it's an hour and sometimes more dedicated to talking about how our life in our careers is going. So agenda is very fluid. Maybe you have recent triumphs to be happy about. Maybe you have frustrations as obstacles to discuss, and maybe all you need is chatting with someone to whom you don't have to define what an affordance is.
Well said. Well said. We've got new recordings of Hci talks going up on our Hci YouTube channel on a regular basis. Some of those need further editing or editing of the captions, and we're going to get to that, but not instantly. Here's a thing I wanted to point out. The steering committee, which meets the first Thursday of the month at 7:30, is open to anybody, whether you are an official volunteer, a curious person, a longtime attendee at these meetings, but not yet involved in the administrative side. And we have three elected officers, the chair, the vice chair, and the treasurer. Currently, the treasurer position is open. So if you know somebody who would make a good treasurer, or if you would like yourself to be part of that, then I would like to hear from you. You could talk to me or Edwin or Ted Selker, who's the current chair. And I'm always interested in getting somebody else to work with me on social media and publicity, and somebody who is looking to have a kind of monthly responsibility. It could be expanded, but right now it's kind of minimal. Okay. I'm playing with my mouse and it's causing some problems. So last but not least, I want to introduce you to Andrew, and you can see him there, and I'm going to let him share his screen very shortly. He's currently at University of Pennsylvania in the Department of Computer and Information Science. And if you look at his own website, you'll find out lots more about other projects he's been doing. But I was teasing Andrew, as I started to say a little before we started the recording, I was teasing Andrew during dinner about having been in the Bay Area for quite a long time, and I'm guessing you were at Berkeley, from what you said, and who your co-authors are. And so you hadn't gotten down to some of those landmark garages and other sites like Park, where we used to meet every month as Hci. So let me stop sharing. And let's see what's happening here. Oh, I know. That's why I can't see you folks. Be here. There we go. So, Andrew, please take it away.
Great. Thank you, Nancy, for the introduction, and thank you all for having me at Hci today. As Nancy mentioned, I was in the Bay Area for about 7 years for my PhD and my postdoc. I had been aware of Hci. I had always been meaning to make it down. Now I'm in Philly, and finally I get a chance to attend the Hci meetings, this time in a speaker capacity. And so this is, I think this is going to be really fun. I'm really excited to connect with many of you who have long histories and many different perspectives in HCI, and to share my own sliver of HCI with all of you. So today I'm going to be presenting a talk called Power Tools for Reading and Authoring Complex Documents. So when I think about projects to work on, oftentimes I think about some of the challenges that arise when we try to share technical ideas in written media. So here you can take an example from my own work, which is scientific papers. I'm constantly reading and writing scientific papers. And when you consider all of the work that goes into reading and writing these, a document like this, as someone is writing a scientific paper, they're going to be making dozens, hundreds, maybe even thousands of these small scale decisions throughout the process of putting together a compelling article. So they might have, they might spend some time consolidating draft material, trying to put together a more concise and compelling account of the ideas that they want to share. They might also spend some time changing some of the concepts in their work, maybe changing a term for something like attention weights. And of course, when they do this, then they have to make changes everywhere else within their document in order to keep it consistent and tell a centralized story. They might also spend a lot of time thinking about formalisms in order to explain some of their ideas. So for instance, the choice of like notation. How do I choose some notation that is going to be understandable to the widest subset of my audience that I can think of? And across all different types of complex information artifacts, these challenges of coming up with the right notation and understanding notation, dealing with the messes that arise through the exploratory authoring process, and dealing with tangled content come up time and time again. And just to pull a few examples of types of information artifacts I'll talk about in this talk, you can consider scientific papers, computational notebooks that data analysts write, programming tutorials that programmers write and read. Across all of these different types of complex information artifacts, we know that not only are they widely written and read, but furthermore that these issues of messiness and complexity manifest in them frequently. So I myself have a background as a software engineering person. I spent a lot of my time programming as well as studying programmers. And so when I thought about what are some ways that we can help people author and read these types of complex information artifacts, I drew a metaphor from the software engineering space, which is the IDE. The IDE is the Integrated Development Environment, and it's a feature-rich interactive editor for authoring and reading code. And in fact, all kinds of features have been built into IDEs nowadays that help with some of these sources of complexity that we've already talked about. So for instance, to understand notation like variable names, well, you can sometimes hover over functions or variables and see the documentation that's associated with that function or variable right there within your IDE. Furthermore, IDEs assist with cleaning. For instance, depending on what language you're programming in, they might be capable of low lighting certain lines of code that aren't actually going to have any impact on the behavior of your program. And so you might be able to just remove them. They also support with operations like cross-document edits. So for instance, I can right-click on a variable, change its name, and then that name change propagates to potentially dozens or hundreds of other places within related files. And the reason that IDEs work is that they rely on these carefully designed interactions that have been developed over the course of decades. And they're also grounded on these sophisticated artifact analyses that take advantage of what we can reason about the underlying code in order to provide powerful tools for people. Which brings me to the vision behind the work that I'm doing, my group is doing, which is developing these things that I call IDEs for ideas. They support the reading and writing of complex information artifacts like the ones that I discussed before by extending interactive reading and writing interfaces and provide this interactivity grounded in dedicated analysis algorithms. And in particular, we've been focusing a lot on a few different components of providing context-relevant explanations of confusing notation and terms, assisting in the cleaning process, and also supporting cross-document editing. So to kind of foreshadow some of the systems that you're going to see in this talk, One of the systems that you'll see provides context-relevant explanations within scientific papers, a project that I worked on in collaboration with the Allen Institute for AI, where let's say you want to understand something like this formula. Well, one of the tools that we built overlays these equation diagrams on top of those formulas directly within the paper, providing these definitions of each of these symbols all side by side with each other in a place where you would want to see them. Another example is an assisted cleaning tool in a computational notebook that helps data analysts clean up after their messes and share their work with others, a project that I worked on in collaboration with Microsoft Research, wherein let's say you're a data analyst and you want to share the code that produces this plot. Well, the tool that we developed allows you to click on that plot and then click the button Gather to Notebook, and then it produces up a cleaned up version of that notebook with just the in-order code that is necessary to reproduce this plot. Another example of a tool that you'll see is a tool for cross-document editing for producing pedagogical programming tutorials, wherein oftentimes these programming tutorials have interrelated code snippets, explanatory text, and outputs. And what this tool supports is linked editing that propagates edits across these snippets, as well as keeping the outputs in sync with all of the snippets within the tutorial by regenerating them live as the snippets change. Of course, in exploring these IDEs for ideas, these power tools for reading and authoring complex documents, we're certainly not the first. And there's actually this really rich tradition within HCI of exploring these different types of affordances. And so to name a few of these, here's a figure that I reproduced from a Hci 2000 paper that came out of Xerox PARC for this vision called fluid documents. And one of the visions of fluid documents was that you would be able to underline terms that people might not understand. For instance, a certain obscure type of grape that might be used in the winemaking process. And then someone could click on that and see definitions of those terms appear as tooltips or in the margins or between the lines. Here's another example that I particularly love, which is that Voyager created a series of interactive books back in the early 90s. A couple of these involved Don Norman, and in particular, you could click on Don Norman and hear additional elaborations about the text as they showed a video feed of him explaining things on the page. So here I'll play a brief clip of Don Norman providing some contextual advice.
That little tiny rectangle, the close box, you have to get the cursor exactly over it and click it in order to get rid of me. Very small, hard to reach, hard to hit. Bad design.
So thank you, Don Norman. If only we were lucky to have you in all of our documents. So there's also a heritage of research and work in developing assisted cleaning tools. So one common example being the grammar checker that appeared in Word as early as the 90s, that even nowadays is capable of telling you when you're using language that could be made more concise and suggesting alternatives. And there have also been a long heritage of tools that support cross-cutting edits. To pick just one, if you consider LaTeX, and you consider the task of, for instance, the choice of notation, where in a document, maybe at some point you decide that you want to entirely change one of the symbols that's used in that document. One of the things that you can do in LaTeX is you can define a macro for that symbol, and then you can use that macro in place of the symbol within the formulas. And when you want to change that symbol, instead of changing it in all of these different places, you just change the macro, and then that ends up propagating to changes of that symbol everywhere that it appears within the document. And so once again, none of these basic affordances is new, but in our work, we consider these ideas of how can we provide effective context-relevant explanations, aids for assisted cleaning and cross-document editing, particularly in a contemporary set of technical media that we think deserves a lot of attention. Programming tutorials, computational notebooks, and scientific papers. And we've explored a lot of different projects in this space, and we've focused on these media in particular because not only are they widely used today, but they also contain sufficient formalisms within them so that you can analyze them and then provide some of these power tools for authoring and reading. Furthermore, one of the things that I really enjoy about this line of work is that oftentimes exploration in one of these columns ends up leading to findings in another one too. So, some of our initial exploration within programming tutorials led us to explore some of these affordances in scientific papers. And similarly, some of the tools that we developed in programming tutorials, we ended up incorporating into computational notebooks, which ended up leading us back to the programming tutorial space to develop yet other types of rich IDEs. Now in this talk, I'm going to be focusing on 2 of these tools in depth, and a couple of the other ones I'll be folding in relevant places where we can kind of expand our understanding of what it means to provide effective support of the types that we're trying to provide. Across all of these projects, I take what I might call like a technical Hci approach, where we have this 6 to 12 month cycle, starting out with conducting these formative initial studies, oftentimes involving interviews and observations and content analyses, leading to the iterative design and implementation of systems, and then evaluating them, often in in-lab studies, often with both a quantitative and qualitative component. And the reason that we combine all of these together is that, I feel that what is missing for designing these systems is the type of knowledge that comes across from all of these different activities, an understanding of how the tasks of explaining, cleaning, and editing manifest uniquely in each of these types of documents. What types of artifact analyses can support interactive authoring and reading, and then designing the actual interactive systems that give users access to these powerful operators. So with that introductory motivation behind us, let's talk about some of these IDEs for ideas, and then I'll conclude at the end talking about some of the areas that we're looking at exploring next. So I'll first talk about our efforts to design effective context-relevant explanations. And in particular, we're going to be talking about scientific papers. This is a project that I undertook in collaboration with the Allen Institute for AI. And scientific papers, we saw scientific papers as an important area to provide reader support, because when you look at a scientific paper, oftentimes you notice that there are lots of acronyms, that there are lots of mathematical symbols, and there are also these newly introduced terms that have never appeared in another scientific paper before. They're the conceptual contribution of that particular paper, and it's something that someone has assigned a new label to. And across a scientific paper, you might actually see dozens, if not hundreds, of appearances of these acronyms, symbols, and new terms. And it ends up imposing a large amount of cognitive load on a reader to keep track of all of these as they're trying to understand the main arguments of the paper. And so our vision for this project was simply, could we provide some type of effective support for readers of these papers where we could surface some of the definitions of these terms and symbols? For instance, the definition of this symbol m sub h to the j, it might help someone to know that this means the self-attended token representation for token t at layer j when they're trying to understand this formula. And one of the reasons that we thought that this was a timely problem to explore is that, like many other areas of NLP, automated definition detection is an area that's seen some recent advances. So for instance, there are definition detectors that provided input of these textual strings like sentences are capable of classifying what words in these sentences are terms, which words together end up comprising definitions. And in fact, some work that was led by one of my colleagues, Dong-Yup Kang, is one of the examples of such a project that has led to some of these advances in the state of the art. Incorporating these state-of-the-art encoders, as well as some additional heuristics in order to end up achieving state-of-the-art accuracy on definition prediction tasks. And of course, this still isn't good enough for production, but it's moving in the direction where we might be able to see in the next 5 to 10 years, maybe these tools could power interfaces like this. Now, the part that I focused on was the design problem. And in particular, the question of, for instance, let's say someone wants to understand the symbol H in this passage, which its meaning is attention head, and it was initially defined on page 3. And it also is used many other times throughout this passage. How do we end up surfacing this information in a usable way to a person? In particular, how should a reader request information about the symbol H, and what information about H should they be shown? Now, to give you a little bit of a sense of this design problem, what I'll task you with is to take just 15 seconds to try to think up your own answers to these questions of how a reader should request information about the symbol, or what information about H they should be shown. Okay, so through this micro design exercise for you, you might have started to recognize some of the challenges implicit in this design task, some of the ones that we stumbled upon as well. First of all, these symbols appear in dense passages where there are many other symbols and where someone might be relying on a lot of the surrounding text in order to scaffold their understanding of that passage. And so any information that you show is going to include other information in that passage, which you want to minimize. Another challenge is that symbols are often understood in context. So for instance, in order to understand this formula, you might not just be seeking to understand the meaning of one of these symbols, but rather all of these symbols and their relationships at once. A third challenge is that symbols are compositional. And so selecting which symbols you want to see definitions for is not straightforward. One question is, how many symbols are even in this equation? And I would argue that there are at least 12. You've got at your lowest level, for instance, on the left-hand side, your M, your H, and the J. At the next highest level, you have the M sub H to the J. So you have at least 12 symbols here, and some of them are encapsulating the other symbols. We need to provide access to the definitions for all of them. Another challenge is that symbols have multiple meanings. So to just choose two appearances of this same symbol T from the same example paper, in this case, in one case, the symbol T is used to mean the number of token representations. And in the later passage, it's used as the matrix transposition operator. And so affordances for looking up definitions should be cognizant of the fact that these symbols might have multiple definitions at different places. And across the process of conducting 5 formative studies, including observations and focus groups where we deployed various versions of this reader, of a reader application, we end up eliciting this set of requirements for providing these context-relevant explanations of terms and symbols within scientific papers, some of which you might recognize from our discussion of minimizing occlusion, consolidating information all into one place, tailoring definitions to the location of appearance, and so on and so forth. And these requirements are ones that we ultimately reified in an augmented reading tool that we called Scholarify. So let me show you what this tool looks like. So the first feature that the tool supports is precise symbol and subsymbol selection. So in order to drill down to that H to request a definition for it, first a reader selects the outer symbol, and then they drill down by clicking again on a subsymbol. Now, once they've clicked on that subsymbol, they get to see this definition tooltip. And this definition tooltip was designed to minimize occlusion while also providing very dense information in one place. The components of it are both the definition, as well as a hyperlink to that definition in context, as well as buttons where someone can open up lists of all definitions, formulas, and all usages of that term in order to collect as much context as they can, as well as potentially look up meaning about multiple senses of the same term. And when someone clicks on one of these links to the passage, it ends up taking them to that passage with the definition sentence highlighted. Another feature that we incorporated was equation diagrams. So when someone is trying to scaffold their understanding of a formula and trying to understand it as a composition of the meanings of many different symbols, well, these equation diagrams are automatically overlaid on the formula on the boundaries of it, with brushing and linking between the labels and the symbols within them. There's another feature that we developed called Declutter, which is to help someone quickly gather as much context as they can about a single term or symbol within a paper. And the way the Declutter works is that when you click on a term or a symbol, then all of the matching passages that contain that term or symbol are highlighted, and all of the other passages in the paper are low-lighted. And what this ends up supporting is that then a reader can quickly scroll through the remainder of the paper in order to try to find those other passages in context that might lend additional meaning to that symbol or term while skipping over the other passages. And across all of these different interactions, our main design motivation was to try to consolidate all of the information about the definitions of terms and symbols into one place without risking occluding the surrounding context and adding additional visual complexity to the scientific paper. To evaluate this design, we conducted a usability study wherein we invited 27 researchers to a remote usability study. And this study included both timed tasks, where participants answered questions that required an understanding of the terms and symbols about a machine learning paper, both with and without our system Scholarify. And they also undertook the open-ended task of reading a paper for 20 minutes of focused reading time with the affordances available. And what we ended up seeing is that when they were answering questions that required an understanding of the terms and symbols, in comparison to a basic PDF reader, participants were able to answer questions in significantly less time while viewing significantly less of the paper and traveling significantly less distance hopping and scrolling around in the paper. And at the same time, they reported significantly higher ease and confidence in answering those questions. Furthermore, when researchers had some focused reading time to use Scholarify, we ended up seeing that the killer features that they reported were definition tooltips and equation diagrams. They were frequently invoked, and when readers were asked to report their anticipated usage frequency of these features, they said that they would use them always or often if they were available in their reading tools. We also started to see some of these emergent behaviors of what it would look like if someone had these tools available. So for instance, we saw readers who were using the tooltips not just to inform them of the meanings of symbols and terms, but in some cases they might have already had a sense of the meanings, and they were using the tooltips in order to check their understandings instead. We also saw, for instance, one participant who read a section by jumping from one equation diagram to the next, believing that some of the most fundamental information about a technical section was encapsulated in those equations, and so trying to essentially short circuit their process of comprehending that section in such a way. Due to the amount of enthusiasm and some of the positive results that we had, this project ended up becoming the start of a collaboration with the Allen Institute for AI, which we call the Semantic Reader. Now, at this point, the deployed Semantic Reader includes the main feature of helping people understand citations by showing the abstracts for those citations. We're continuing to work on some of these features around definitions, as well as some other experimental features as well. So if you're interested in keeping tabs on this, you should look up some of your papers in Semantic Scholar, and occasionally you might see some of them supported in Semantic Reader, where you can start to play around with some of the affordances that we envision in the future of reading applications. Now, part of the project of building one of these interactive reading tools is to do the design work of, for instance, figuring out what navigation, highlighting and lowlighting and diagramming looks like in one of these reading applications. But the other component that we're also focused on is, for instance, how you do the underlying analyses to enable the user interface, and if we might be able to help set an agenda for how these analyses should evolve over time. I've already talked about definition and detection and how it's this field that has this growing promise for being able to support applications like this. And some of the other places where we were essentially scrounging together various techniques occurred in the space of trying to localize symbols and various entities within papers. And so here I just want to give you a little bit of a sense of the types of hacks that go on behind the scenes in order to enable the types of interactions that we're exploring in a tool like Scholarify. So let's just ask the question of how someone might automatically find a precise position of a symbol within an academic paper. Well, the tack we ended up taking is that let's assume that you have the LaTeX available for the paper, as is the case for for over 1 million papers that are now hosted on the arXiv preprint service. Well, if you have the LaTeX for a paper, you can render that LaTeX, and then the appearance of that LaTeX will be something like this rasterized bitmap that you see on the right-hand side. And in order to find the equation within that LaTeX, one thing that you could do is you could surround the LaTeX for that formula within coloring commands. And if you were to re-render this LaTeX, it would end up producing a PDF with a bitmap that looked like this, with that visual pop around that equation. And then you could difference these two images from the original PDF and the altered document in order to get just these colorized pixels. Once you compute the bounding box that surrounds these pixels, you end up getting this precise bounding box for that equation. And furthermore, you can take it one step further and do this for symbols as well, once you parse the LaTeX for those equations and understand where the constituent symbols are and understand how those symbols and the sub-symbols relate to each other. I can describe more of this during the Q&A session if anyone's interested in it. It starts to get kind of down into the dirty details. But the most important thing here is that when this idea of perturbation of the underlying source is extended to detecting individual symbols, it ends up leading to high accuracy symbol detection, the precision of 96%, a recall of 88%, which starts to look like the levels of accuracy that we might be able to provide that might be able to support these intelligent reading applications. So now that we've talked about an example of providing these context-relevant explanations to support the reading process, I want to switch gears to thinking about how to support authors in producing some of these types of complex documents. In particular, we're going to focus on this feature of assisted cleaning. And we're going to focus on the medium of computational notebooks. So some of you might have heard of computational notebooks before. Some of you might not have used them before. So let's just start with an introduction to computational notebooks. Computational notebooks are what might be called a literate computing medium for being able to write up these rich narratives about data analysis activity. And when you look at a computational notebook from an execution semantics perspective, it has a few features. So first of all, within a computational notebook, code is written incrementally. You write it a few lines of code at a time, and then you submit each of those lines of code as these self-contained cells, one at a time, to a backend interpreter, which executes just those lines within those cells. Another feature within the computational notebooks is the ability to include in situ outputs. So as you're computing some of the results, for instance, showing some exploratory statistics, or maybe plotting out some clusters of your data, you can include those plots and those descriptive statistics right there next to the code that produced them. Another feature of these computational notebooks is that you can make these incremental changes because of the way that the execution works. So for instance, here you can see a data analyst changing the number of clusters of this irises data set and continually updating some of the visualizations within their computational notebook. And here you can see they're cleaning the data in a different way. And essentially, you can just change a little bits of this code at a time and re-execute that code in the localized parts of the computational notebook that relate to it. The fourth feature of computational notebooks is control over layout. So for instance, these cells and their outputs can be arranged in any which order that someone wishes to arrange it, either for expediency of exploration or ease of explaining the contents. Now, one of the challenges in these computational notebooks arises when someone comes back to this computational notebook, and then they might have a result that they want to share with someone else. They want to describe their analysis process with someone else. And the problem is that these computational notebooks no longer have the information necessary in order to convey how precisely this result was arrived at, because some of that information may have been overwritten or might be ambiguous on the basis of the ordering of the cells within the computational notebook, based on just the design of that computational notebook. And so what we wanted to do with this project was assist in the cleaning process of this computational notebook of sharing some of these data analysis results with interactions that were as simple as making just 2 clicks. And these 2 clicks are as follows. First, a data analyst picks a result that they want to share, like this plot. And then the second click is clicking Gather to Notebook. And what this is going to do is what we call gathering the code, which is producing a subset of the code from the original computational notebook that is reduced in size, it's ordered, and it's complete. And what this means is that someone else would be able to rerun the cells in this notebook in order to reproduce the same results, something that wouldn't have been possible within the original computational notebook. And one of the things that occurred to us is that once you have a primitive interaction like this, it might be able to scaffold the data science exploration process in other types of ways as well. So for instance, one of the things that you might be able to do is allow someone to click on a result in a computational notebook and answer the question of how they produced a previous variant of this result. And so what you saw was someone clicking on a plot, and then they clicked on Gather to Revisions. And what this shows is essentially a set of fabricated computational notebooks for each of the different versions of this result. At the very bottom, you can see the different variants of the plot that was produced. Up above, you can see the cleaned, ordered, reduced subsets of code that end up leading to reproducing those results. And then you can also see that we show these cell by cell fine-grained differences to help call someone's attention to what changed across each of those different versions of the analysis. In this way, thinking about cleaning as something that is not necessarily something that happens just once at the end of exploration, but something that might feed back in to authoring one of these documents. So just as with the Scholarify project, when considering a tool like Gather, we can consider it not only from the UI perspective of how we support selection, previewing of clean content, versioning, and so on and so forth, but also the necessary artifact analyses in order to enable these types of powerful cleaning tools. And the main techniques that we used for gathering in computational notebooks is techniques called dependency analysis within program analysis. And in particular, we relied on a tool, on a technique called program slicing. And the way that program slicing works is that, let's say that you have a program like the one showing on the screen right here. Program slicing is the process of taking a program, splitting it into a series of atomic statements. And then what you do is you determine all of the data dependencies between those statements. So for instance, cases where one statement uses the output produced by another statement. And you also compute the control dependencies. And those are cases where one of the lines of code essentially makes a decision as to whether or not a later line of code will run or not. And your slice is essentially taking a specific line of code from that program and then computing all of the backwards data and control dependencies. And that's your slice. That's the subset of code that is necessary for that statement to run correctly. And the way that this ends up plugging into the notebook experience is that, well, you can't slice a computational notebook because some of the cells are missing and some of the cells are out of order, as we showed in that vignette earlier. And we still want to produce these cleaned and ordered notebooks. So the way that we do this is that we actually keep track of an intermediate representation called the execution log. This is all of the lines of code that have been seen in order by the interpreter. And what we do is we then cross-index this execution log into the notebook. And then when someone clicks on a result within the notebook, we essentially use it as a slicing criterion in the execution log. We compute the backward slice using the program slicing, using a conventional program slicing algorithm. Here I have a reference here, which is an interesting piece of trivia, which is that this program slicing technique was, one of the first program slicing techniques, is one that was proposed by Mark Weiser, of all people. One of the major proponents of ubiquitous computing many years ago. Even before that, he was working on programming tools as part of his dissertation work. So we have him to thank for some of the ideas behind this work as well. And once you've computed a program slice like this that's cross-indexed with the original notebook, then you can end up producing these cleaned up and ordered notebooks. And by extension, some of these versioned results where you just use different versions of that result as a slicing criterion. And that's what it takes in order to produce this advanced cleaning operation within a computational notebook. Now, to get a sense of how a cleaning operation like this might support the creation and maintenance of a notebook, we observed 12 data analysts during both notebook cleaning tasks and exploratory data analysis tasks with Gather available. We were interested in seeing how it supports the cleaning process and the authoring process more generally. And our first finding was we delved deeper into what these authors even thought of as the cleaning process. And so our first finding was that they described the process of cleaning as something that was essentially analogous to the Gather process of picking a subset of cells and removing the rest. But what we also saw was that the process of cleaning in their minds included many additional stages as well: writing documentation, merging cells together, polishing visualizations, restructuring code, and so on and so forth. We think all of these make for really interesting opportunities to explore in future work on authoring tools within computational notebooks. When participants were asked about their perception of some of these features, they almost unanimously described the tools for gathering to a new notebook as very useful, with the process, some of the tools around highlighting dependencies to also be somewhat useful. The version browser was seen kind of more as a mixed bag. Some of the participants didn't even encounter it during the usability study session. But for this kind of core feature of gathering to a notebook, it was described as beautiful and amazing. It hit the nail on the head. This was a feature that clearly resonated with those data analysts. And that one feature ended up being appropriated in many different ways during an open-ended data exploration process. So in particular, some of the different ways that we saw this cleaning aid being used was as a finishing move at the end of the process, at the end of the exploration process in order to produce a cleaned up version of their notebook. We saw authors gathering code in multiple different ways for multiple audiences. For instance, one notebook that included more visualizations for one audience, one notebook that included more code for a different audience. We saw participants using Gather as a lightweight branching tool in order to essentially take a snapshot of some of their exploration and put that off to the side. We also saw them creating personal references for themselves, for instance, visualizations that they wanted to refer back to as they continued their exploration. And there was so much enthusiasm for this project that it ended up becoming a feature incorporated into the Visual Studio Code tools for computational notebooks. So here you can see a demo of an enthusiastic YouTuber describing how to gather the code required to generate a cell in a new notebook right after the release of this feature within Visual Studio Code. And we also have an open source reference implementation of this project. Of course, it's a couple of years stale by now, but it includes some of the foundational program analysis that we used in order to support the Gather interaction for other people who are interested in building out toolkits like this. Now, I think that maybe one of the shortcomings of gathering as a kind of a paradigm for assisted cleaning is that it's essentially kind of like it's like a shop vac when it comes to cleaning, and that it's kind of like a one-stop shop. You turn it on and things are clean. So you select a slicing criterion, it selects the relevant lines of code, and that's just kind of the end of the story. And another way of looking at this is that perhaps cleaning should be more of an incremental process, maybe more akin to sweeping instead of a shop vac, where you make these incremental choices about what should get included, what shouldn't get included. Maybe you can make some direct changes to that document as well, essentially kind of sweeping some of the details under the rug, so to speak. And so, this idea of incremental cleaning is one that we explored in a project that I call Code Scoop. And in this project, we imagined the scenario for incremental cleaning of someone trying to create a code example from an existing software project, where you start with this complex monolithic program with lots of source code in it. And through the process of simplifying that code, making choices about what to include and what not to include, you end up turning this into a concise, self-contained code snippet. Now, what are some of the circumstances under which someone might produce one of these snippets? Maybe you're making a code example to share with your class of students, or maybe you're a software engineer and you're trying to share some know-how about how to use an API with one of your peers, or maybe you're an API documenter and you want to add some examples to your documentation. So those are some of the circumstances that we imagined with people trying to create these concise self-contained snippets. And over the course of observations of 12 programmers who were trying to create samples from their own programs, we saw that cleaning was very much this incremental process. And so here's kind of a cartoonized version of one of the programmer's workspaces, where the two most important elements here is that you've got a text editor where this particular programmer was creating a code example. And then you have this other editor, which contained their original program that they were trying to extract code out of in order to create their sample program. And some of the challenges that we saw in the cleaning process that might benefit from tool support were things like transcription errors, where someone ported code over from their original program into their example program and they made some error in the process. In other cases, sometimes they forgot code to include within their sample. In other cases, when someone tried to create one of these samples by removing code from their original source program, sometimes it was just really time-consuming to do so. In addition, when a programmer tried to make edits to the code example in order to simplify it and make it more usable, they ended up introducing errors some of the time. So these were all things that we thought could be kind of core features within an incremental cleaning tool. And so the basic idea of this tool, which we called Code Scoop, was like, let's say that you have a program like this one, which shows someone how to use a database API. And let's say that this source program was this delicious ice cream that you can see right here. What we wanted to do was to enable someone to essentially scoop out the relevant code through multiple passes, add cherries on top through certain types of ornamentations and simplifications. And hence we call this project Code Scoop. So let's drill down a little bit more into what this incremental cleaning process might look like and what those choices might be in the cleaning process. So this is the Code Scoop editor. And just like with Gather, it all starts with an initial selection. Here is a line of code at the core of the usage pattern that I want to share with someone else in a code example. Now, one of the first things that you'll notice is that after I hit scoop, there's this extracted example that appears on the right-hand side. This is essentially my docket of work where I'm going to produce my example through incremental cleaning interactions with Code Scoop. And the way that Code Scoop works is that you have these fine-grained selections of code. Instead of pulling it all out at once, you pull it out incrementally. So in cases where there's ambiguity as to whether or not you want to include code, so for instance, this for structure, for instance, this other while structure, you can see it highlighted in the original source program as I consider each of these options, this try structure. In each of these cases, I get to review whether or not I want to include that code. And similarly, what you just saw was someone reviewing whether or not to include past variable uses of a certain core variable that might have changed the semantics of the program. And so each of those choices where there's ambiguity in selection, those are surfaced to a programmer in a way that highlights the context in the original program that someone might want to consider. The other feature that Code Scoop provides is it allows for these in-place simplifications. So for instance, instead of adding additional code to define a variable, I can just substitute a value that that variable takes on during program execution. For instance, the value for this query in place of the query variable. In essence, being able to remove these incidental details and complexity from the example through this kind of incremental cleaning choice. So we conducted a usability study of this program for incremental cleaning, where we had 19 undergraduate student programmers create snippets from existing programs, both with Code Scoop and a baseline text editor. And what we ended up finding out was that compared to the baseline, participants finished creating code examples in about half the time. They found it easier to use, more enjoyable to use, and they also believed that it produced sample programs that they were more satisfied with. And these deltas that you can see in that third column, each of those are deltas on a 7-point Likert scale of the median rating of ease, enjoyability, and satisfaction. So those margins ended up being relatively large. And we ended up seeing that this incremental cleaning assistant ended up leading to some flexibility in the types of sample programs that people produced. So for instance, here's an example of two different programs that were produced from the same source program in response to the same prompt. You can see these two different versions of a program for extracting a certain field of data from a database. And in the left-hand program, you can see that there are more guards in place for error checking with the try-catch block and that if condition. And in the right-hand block, you can see a little bit more semantic information about kind of a scenario that's taking place with explicit variable names for the columns, as well as data types for the extracted title and for a book object that gets created from the extracted information to show a little bit more about what someone might do with that data. Two different approaches that kind of demonstrate two different sets of pedagogical goals. And if you take a step back, and just take a look at all of the different places where there were these decision points, you see that there's quite a bit of variation. So in this visualization that you can see here, you can see each of these rows is a different variable about which an author can make a choice as to whether to fix a problem with fix a problem in the example by adding additional code that defines that variable or by inserting a literal in its place. And you can see for almost all of the variables, you have some of the participants who chose to fix it by adding code and some of them who chose to fix it by inserting a literal in its place, showing that this flexibility ended up becoming used by some of the participants. So the main takeaways from this line of assisted cleaning work is that these tools have made cleaning more efficient than using the baseline text editors alone. And furthermore, that they've provided flexibility in determining what content should remain in the cleaned document. So I want to conclude with a brief description of one of our tools that we've worked on in the cross-document editing space. This is another one of the authoring affordances that we discussed. And for this project, we focused on programming tutorials. I think programming tutorials are a really interesting case for exploring cross-document editing. And this is in particular because there's a lot of interrelated and tangled content. So here on the left-hand side of the screen, you can see a visualization of I believe the author is Mike Pomek's Cameraman's. He created this beautiful tutorial about how to create a very simplified version of the Super Mario World game using processing. And within this tutorial, you can see kind of three main components that appear in lots of programming tutorials, which are first written textual instructions about how to compose a program, code snippets of which a program is eventually built up, and then also the expected results, for instance, outputs. In this case, within this tutorial, at various checkpoints throughout the process, you can actually click on the rendered Mario game and play around with it in order to see the latest feature that you've added to Mario in the latest snippet of code. And the problem comes when you think about the larger context of producing one of these tutorials, where an author might start with a source program and then they have to produce 41 snippets and dozens of snippets and dozens of outputs, all of which are very related to each other and sometimes dependent on each other. We built a tool called Torii, T-O-R-I-I, in order to try to help facilitate the process of authoring these programming tutorials, in particular by managing some of these cross-document edits. So in Torii, essentially on the in your left-hand pane, you have a source program that you're trying to teach someone how to build. In the right-hand pane, you have the programming tutorial that you're creating that's going to describe someone how to describe to someone how to build that program. And then Torii provides a couple of simple affordances to help with these cross-document edits. In particular, it provides this linked editing between snippets. So if the same code appears in multiple snippets, if you change it in one place, it ends up propagating to the other place automatically. It also supports linked editing between the tutorial and the source program from which it was derived. So for instance, if you go back to your reference source program and want to tinker around with it a little bit, check what the outputs might look like if you change some of it, as you change that, those edits can propagate back to Torii live and in real time. And the third feature is having these, essentially having this almost live programming environment where as you're changing some of these snippets, the outputs are going to change live. So I can change, for instance, the 90 parameter in the shape initialization, and then you'll see the print statement down below immediately update to the new value of that rectangle width. And the kind of magic within Torii is a certain computational model that we explored that could keep track of how all of these snippets should relate to each other and how they should essentially be kind of combined in order to produce these outputs. When we performed a usability study wherein we had 12 tutorial authors, both create tutorials and edit tutorials, we wanted to ask the question of how Torii supported the process of authoring and editing these tutorial documents. And we saw some of these instances of flexible authoring choices that were supported by using Torii. So for instance, to take a look at just this one tutorial that was produced by one of the participants in our study, you can see some of these tropes of flexibility. So you've got these fragments of code, which if you were to execute them in a conventional notebook paradigm, they would lead to syntax errors. But in this case, Torii is capable of keeping track how they should be combined with the snippets later to produce these syntactically correct underlying code that produces the outputs. You can see cases where code is repeated multiple times and it's embellished with additional code after some of the kind of prior after some of the most important concepts and most important elements of the code are described in earlier ones, then it's further embellished later. And again, Torii keeps track of when code is repeated and only includes it once when trying to regenerate these outputs. There was code that was hidden that the author wanted to be included in producing the outputs, but didn't want to be shown to a reader because it would be too distracting. And then there are these generated outputs that were kept up to date live. And across all of the participants, we saw that about half of them made use of this pattern of repeating code multiple times. One of them presented code out of order that it would need to appear in order to be syntactically correct to an interpreter. And then 3 of them also fragmented their code, splitting up the declaration and implementation of a class and method in a way that they wanted to surface the signature of the method or class first, and then talk about the details later. So, having reviewed some of these various tools for context-relevant explanations, assisted cleaning, and cross-document edits, I want to give you a sense for the way that we see our overall approach to this space and our agenda of some of the projects that we'd be really interested in working on going forward. So kind of the meta perspective on this research agenda is that in pursuing these tools in the IDEs for IDEas toolkit, we take as priors a set of artifacts, these complex information artifacts, as well as existing algorithms and models that might, in the near future, end up being able to lead to these augmented reading and authoring experiences. And then we end up contributing back these augmented artifacts, as well as ideas for how to improve these algorithms and models. For instance, in the case of the Scholarify project, understanding that definition detection is a space that's increasingly seeing some really promising results, and that there are document parsers and increasingly large sets of documents for which you can do the type of document processing that we wanted to do, ultimately leading to the development of an improved definition detector and improved document processor, improved document parser. And all along the way, doing kind of my own bread and butter of revealing hidden needs in the reading process, as well as defining new types of, defining interaction methods to a degree of specificity that we think that, that this might indeed be how they would be reified in the future. And we explore this idea across this larger space of these 3 affordances and these information artifacts, once again exploring them in parallel in order to try to understand, affordances that might show up in one space that might end up manifesting in a really positive way in another one. Now, as our group looks to the future, one of the obvious places to look is simply some of the areas in this space that we haven't explored yet. So let me highlight some of the areas that I think might be some promising areas for future work. One of these is trying to further improve our ability to make effective explanations of how to program systems. So in particular, how can tools help authors create easy to read programming instructions? I think that there's 2 components to this, both an interaction design component as well as a systems component. For us interaction designers, I think that there's some work to do on first just defining what makes a snippet readable, reusable, and easy to integrate into one's project. This was an effort that I started, the effort of trying to define this is something I started with a literature review in my own dissertation back in 2020, and one that I think is ripe for further studies. And then there's also a systems challenge of trying to leverage dependency analysis in order to decompose some of these complex systems into underlying snippets of which they're composed. And then maybe we can apply some program synthesis, evolutionary programming, code generation techniques in order to help people select parts of the code that are too complex and maybe provide more effective, ambitious simplification suggestions. Another area for exploration is, for instance, trying to make better explanations in data science, as well as support cross-cutting edits. So I think there's this question of how can tools help authors construct interactive data narratives? On the right-hand side of the screen, you can see an example of an interactive data narrative, where someone can explore the impact of bias in loan-making decisions by changing some of the thresholds that are used in loan-making decisions. And you can imagine that in order to design an effective interactive data narrative like this, you have to understand what it takes to author a data narrative like this, which might be this very error-prone or tedious process. And furthermore, it also requires an understanding of what are the most instructive forms of interaction within with data within a narrative like this that's going to lead to people thinking about the right kinds of things and leading them to the right types of takeaways. In order to support interactions like this, you also have to build systems that perhaps automatically explore parameter spaces that someone could explore within these interactive data narratives to find notable areas of exploration. And perhaps there's also work to be done on linking textual descriptions within the text back to the visuals in order to help people understand a message that relies both on the text as well as the nearby visuals. Another area that I think is ripe for exploration is understanding how tools can support the cleaning of scientific text. So for instance, And maybe it's not too much of a stretch of the imagination to imagine some of the tools, some of the techniques that I've already described within this talk. For instance, definition detection of symbols in order to support the cleaning process. So for instance, you might be able to detect that T has conflicting symbol senses in multiple parts of the same document. And then you might be able to recommend to someone to choose notation that's going to be less confusing to people. Furthermore, as you start thinking about some of these places where we're seeing these exciting advances in, for instance, fact-checking, theorem proving, text summarization, coherence checking of texts, and text simplification, all of these, I think, are affordances that could plug into some of our interactive document editors to lead to people producing better, cleaner, easier to read scientific texts. And furthermore, why even stop there? You know, within this talk, I've talked specifically about programming tutorials, scientific papers, and computational notebooks, because it's a place where formalisms manifest within these documents in such a way that you can perform the analyses that enable the interactions that you might want. And as we continue to develop better techniques for processing increasingly more abstract media, like digital textbooks, Wikipedia articles, orchestral scores, and so on and so forth, I think it would be really exciting to continue to explore how to augment the authoring and reading process for all of these different types of documents. Okay, so that's it. That's the talk. At this point, I'd be really excited to take some of your questions.
Sorry, I was muted. Thank you so much, Andrew. And folks, I see that there are several questions in the chat. Andrew, I think you probably didn't have a chance to look at those. And Lisa was commiserating there about the need for stuff. Suyash, do you want to ask one or two of your questions aloud?
Yeah, sure. I came in midway, but I really like the presentation. My one question is, where can we try these tools out? Is there a website where you have all these? And second one is, I particularly enjoy data visualization, and I love New York Times data visualization based articles, and I would like to create, some of my own. Like the ones you showed, where users can interact, and also something I've found is called interactive nonfiction. Where can one learn more about how to make better data visualization that can not only teach but also tell story and engage the audience?
Great, sure. So okay, so your first question is, where can you try out some of these tools? So the first place that I would point you to is that for each of these tools, I have essentially kind of an immortalized version of the demo of the tool from the time of the usability study that was conducted. And you can find all of those on my website, for which I have a link on this question slide, https://andrewhead.info. And so there you can find demos of the CodeScoop tool, of Gather, of Scholarify. I don't think I have a demo of Tori up on that website, but for all of those other ones, there are demos. In addition, for the Gather tool, that tool has been incorporated into the Microsoft Visual Studio Code IPython Jupyter Notebook extension. And so you can try it out by installing that extension within VS Code. For the Scholarify features, we're continually working on the tech backend for it. So if you wanted to get a sense of how some of these features might eventually look, you can go to semanticscholar.com, look up some papers, and the one main feature that's incorporated right now is citation highlights, where you can click on those citations and see abstracts for papers. I'm hoping that in the coming years, we'll increasingly see some of these intelligent features, like the definitions and terms that I was describing in this talk. So those are some places that you might want to check out. So for your second question, thoughts about what it takes to come up with these effective visualizations. So I think that there are a couple of places that I would take a look. So first, Matthew Conlin and Fred Homan have an article that I think is titled Communicating with Interactive Articles. I might have gotten the name of it incorrect, but if I did get it incorrect, you can send me an email and I can look up the citation for it. And so this is an article that they posted to the Distill online interactive publication. And it's this review of dozens and dozens of interactive articles that include visualization and interaction and all of that kind of stuff, classifying all of the different roles that interaction plays within these documents. And so I think it's a pretty well thought review of all of these different types of artifacts, articles, and how visualization and interaction manifests. I'd also point you to a couple of classics. So for instance, the Edward Tufte books on visualization are, for instance, I think Envisioning Information is one of them, and I might get this wrong, but the visual design of quantitative data. Someone can probably correct me in the chat on that one. Visual display of quantitative data, maybe perhaps that's it. I think are two classics that you may have already come across that have collated a lot of wonderful examples of effective visualization patterns when you have a complex message that you might want to communicate. And the last place is that if you're feeling intrepid, you can also look at the information visualization proceedings, where the idea of creating some of these data narratives is an area of increasing interest, and where you'll see a few papers at that conference and related conference each year.
Okay, other questions, please. Carl, do you want to ask or offer your suggestion?
Sure. Yeah, there's a trend of doing more visual abstracts in some journals to try to simplify key findings. Have you looked at all at that aspect of generating that? Those, I mean, you were doing the more interactive one example there, but
yeah, that is really interesting. So here, maybe I can shoot the question back at you a little bit, admit some of my own naivety. So these visual abstracts, are they essentially kind of like a poster or like an infographic that includes like some of the figures and a few sentences about main results, or like what are they made up of?
Well, part of it's for conveying, for non-English speakers, for instance, and able to look at a glance of, like in some of the medical journals, COVID, I think has accelerated the use of those and trying to show what the results are. This got this kind of results out of, using this drug or something. I don't have, if you search for that, I'm sure you'll find lots of examples, but I can't explain any more than that right now.
Okay, great. Yeah, that is really cool. So I personally am not too familiar with the practice of using visual abstracts. It sounds super useful. I think it's an interesting area to explore. I will say that I think that there is this I think that there's this big space for people producing artifacts like those visual abstracts in order to make the insights of their scientific research more approachable. And so you can think about things like blog articles. You can think about things like tweet threads. All of these cases where in order to provide some really useful information to a broader audience, one should think about a different medium and different conventions of communication. And one of the reasons why I think that, the suggestion that you made is a place of great leverage is that I think that a lot of scientists are not trained, as they are in writing papers, in writing in some of these other media, for instance, producing visual abstracts or blog articles and that kind of thing. So we certainly aren't actively working on anything in that space, but I think that it's a really astute observation that, there's different media for communicating with different audiences. And I think that there's a long way that authoring tools can go in order to support people in producing those artifacts.
Thank you.
Yes, Alec.
Yeah, nice listing of projects, Andrew. Thanks. I'm looking for sort of the thread through is who are all the people involved here? In the strict case, which says something about how you shade some of the features you're trying to support. For instance, in a textbook writing case, think of your freshman year or high school calculus book. There was the author of the book. There's the there are the readers of the book, the students, but there are also the instructors that are using the book. In the case of a program, often the audience is really the execution platform, which is going to give you ground truth, and the compiler stands to hopefully helping you along the way. There may be a human being that actually uses or perceives or interacts in some way with the output of that program, like probably in most cases. But these are different sorts of roles. The primary ones that as I was going through was author and let's call it reader. But even in the scientific paper, there's, you got to get it past the reviewers. So, they're there in some form, even in a formal case, even if they're just doing fact checking. So how is there searching for sort of a calculus of people involved in the digital artifact production and use right there? You're just being bimodal about it. But do you have, could you outline that for me? And what sort of drives your work from that perspective of who's involved?
Yes. So it's a great observation that with each of these artifacts, there's a really diverse set of stakeholders who end up intersecting with this document in a lot of different ways. And so I guess even to flesh out the case of readers, I guess to give a little bit of credence to what you're describing, to think about readers of scientific papers, as you mentioned, you have peer reviewers, but you also have students who are reading it as part of a reading group or a course. And you also have researchers who are reading it in order to stay apprised of the latest research. And you also have researchers who are reading it in order to try to replicate the results, which requires a much deeper understanding of the underlying paper. And so, this is just, and those are just four of many different types of stakeholders within reading the paper. And so the way that I tend to think about this when we work on a paper is, Dan Olson in his own WISC paper about evaluating user interface systems research, he talks about thinking about situations, tasks, and users when you're trying to decide on which of the projects to work on and evaluating the importance of it. And so, one of the things that you might notice is that the idea of understanding abbreviations and mathematical symbols, well, that's something that, like most readers of an academic paper, if they get to the methods section, they're probably going to need. The task of creating a code snippet, if you consider it broadly construed, not just for API documenters, but also for software engineers trying to kind of share, know-how with each other. It's also an audience that you might have like millions of people. Cleaning up a computational notebook, also, potentially millions of people if you consider the, very broad number of people who use a platform like Jupyter Notebook. And so when focusing on a particular audience, I try to think about scale. Is this going to be useful to a lot of people? And is it also going to potentially eliminate a lot of time for them or enable them to, in the case of reading, jump to cognitive conclusions with all the extra headspace that they have afterwards? And so this is something that's very much in the back of my head. I don't have any hard and fast rules about which particular group of users is necessary is the right one to support. But I think it's important to take that mental calculus into mind when working on these projects, which is that, presumably you want these tools to be used by a wide range of people. And then also the itch that they scratch is a big itch.
Yeah, thanks.
Well, I'm going to come at it from a different direction before I open it to Lisa, because I think she's more on your target. But I am struck by the fact that you're creating a bunch of tools which have great usefulness for a group of people. And yet it seems to me, you haven't taken any steps to assure the accessibility of the new tools.
Yeah.
So how can you be inclusive while still being creative?
Yeah, I think that's an apt point that accessibility is not something that is factored prominently into some of our designs of these tools.
And then you can't make the argument that there are so many Braille readers that you have to be able to provide, or, there are certainly
that's right.
so many people who use JAWS or one of the other speech, text to speech and navigation around the screen kinds of tools, right?
Yes.
And you're
yes.
creating these tools that have effectively a visual overlay in a sense. So I don't know
Yes.
how you point at them appropriately for that audience.
Yeah, that is a really good point. So I guess my answer here is that I think that you've revealed a place where I think we really do have our work cut out for us. The idea of showing like how do you describe a visualization of a slice that's overlaid on a program? Do you read off all of the lines, or do you like summarize the number of lines that have been selected and their approximate distribution? That is a tricky design problem, and one that would need to be solved in order for this tool to be accessible. So I can tell you that at least as part of some of these, so as part of some of these partnerships, I'm lucky that, for instance, in some of the work that we've been doing with the Semantic Scholar team, there are people there who luckily know a lot more about accessibility than I do, and that I'm learning a lot from, to ask some of these questions of, for instance, if you have a label appear on a page in a tooltip, how do you read off that text to someone else? And so all that to say, I think in these places where we are actually working towards wide deployment, that's a place where accessibility is a big concern, and one where I think we'll have some interesting things to say within the next couple of years. And this has become, just so you know, because you're still working in a research environment, you haven't productized these things, but this is in fact one of the criterion for whether a company will adopt a tool, right? And so, that's like really important to have it built in early, so that it's going to be adoptable, right? Yes.
Anyway.
Absolutely.
You got my point. Lisa, go ahead and talk about your Jupiter situation.
Thank you for your point, Nancy. It's a great point.
That's a really good one. Okay, so a couple of things come to mind. First of all, I have been, intensively learning to code for the last 3 years, 3 years, pandemic time. So this is very close to the bone for me. So the first thing that I wanted to ask you. The amount of time that I spent learning in my class, my R class, I spent more time trying to deal with Markdown and documenting using Markdown than the programming stuff that I was learning with R, and that has continued. So in my experience thus far, Jupiter. And I don't remember what it was we used in our class, but I think it may have been Jupiter. But anyway, that's kind of my question to you is, what are you doing about the learning curve for Markdown?
Oh, that's really interesting. So I guess maybe to shoot this question back at you too. Can you tell me a little bit more about what your experiences have been with Markdown and some of the obstacles? So has it been, for instance, knowing the proper syntax for the various tags, or is it like, even the challenge of being able to preview what that Markdown looks like and kind of visualize what it's going to be in your head before you click out of that cell and it gets rendered, or
not the visualization. No, that's not the problem. It's the coding, and syntax. Being able to switch into that headspace. To do that when I'm already, my objective was in learning these concepts and, what's going on with the particular language I'm focused on, R. It takes me out of that space. And now I'm, that's the problem is just knowing the language. You know what I'm talking about, right?
Yeah.
So,
yeah, totally. So I guess, there's a couple of things that I think should maybe be more pervasive within some of these literate computing environments like Jupyter Notebook, which is better discoverability and I guess reducing the gulf of execution when it comes to trying to come up with the right syntax for Markdown. So one of the features that you'll see in some code editors these days is that you've got kind of Microsoft Word style widgets for doing things like formatting headings and bolding text and, formatting certain parts of that Markdown as inline code chunks and that kind of stuff as well. And so, this is something that hasn't really made its way into Jupyter pervasively, I guess, at least, the last time I checked. And so, I think that that's one place where that syntax problem could be better addressed. So, I'd be interested in your perspective on whether that might fit the bill, and we can talk about that if, depending on what other questions are present. But I'll also offer something else that's, maybe a little bit future looking too, that I think that there's also a lot of work that goes into writing that Markdown, from thinking about what to write, how to describe your analyses, and keeping it consistent with the rest of the text. And I think one question that maybe we should be asking ourselves as researchers is like, how do we help people write some of that documentation? Is it possible to, help people notice when there might be oversights in the way that they're describing their analysis algorithm, where they might benefit from additional introspection in writing that documentation? And can we probe them a little bit to produce that? And in other cases, when, for instance, you say, my results are great in the Markdown, and then you re-execute your code, and all of a sudden your accuracy has tanked in your most recent version, is that something that you can somehow propagate back to that Markdown? And so I would say that there's both, there's certainly ways that you can help with the syntax, and I think some of the other things that are going on with that Markdown too. Perhaps they should be some of our part of our vision of future interactive authoring tools as well.
Yeah, great. Now I have one other thing I wanted to ask you about. I find that, and I'm not alone because I'm teaching, and I see my students really gravitate towards this. In teaching programming concepts, I use drawing a lot, more and more, to abstract, what is going on, the bigger picture, the ecosystem. Is really fundamental work, where that's what I've found in working with students, and it has been fundamental for me. I will work out something by drawing it, right? But I'm not clear on how would that, are you doing anything like, do you, provide for that in the research that you're doing and the experiments that you're doing?
Yeah, so we haven't yet explored much in the pictorial space of, for instance, if we were to generate a visualization of the code and what it does, how would you generate that on the behalf of an author? I think that there's one line of work that perhaps you've encountered some of the outputs from, which is that Philip Guo a few years ago created a tool called the Online Python Tutor, which is a tool where you can essentially plug in an arbitrary piece of Python code, usually maybe a few dozen lines long in terms of the complexity of the program. It will automatically visualize the in-memory contents of the Python program at each step of execution and allow you to drag back and forth. And so I think that that's a good proof of concept, that it's possible to produce some of these visualizations automatically, at least if the program is sufficiently simple and the way that you want to explain the program. There's something that I've thought for a long time would be a really cool project to work on, which would be, helping people comprehend more complex software programs through visualization and kind of, conceptual tagging of those projects. So for instance, can you help someone navigate a code base and understand which parts of it are model, view, and controller, which are often separated in very disparate places, and it's kind of hard to see from the syntax alone what those pieces are. And so I think this overarching question of helping people connect complex concrete representations of the code to more expedient abstract representations is a really great insight. And I think we need to keep thinking about places where we can gain purchase in that space where there's that kind of tractable problems.
Well, can I just mention one more thing, and then I'm going to be quiet for, because I know we've got a lot of people here. The thing about this is that when I'm drawing and my students are drawing, it's a very personal representation that they're making.
Oh, that's interesting.
leveraging somebody else's concept might look great and makes total sense, but it's not meaningful or as meaningful
Yeah.
to me because I have my shapes and my, you know what I'm saying? And
Yeah,
so do
yeah,
the
right,
students.
right. Yeah, totally. And so I think one of the tensions that I feel like you're also pointing out, Lisa, maybe not directly, but perhaps indirectly, is that I feel like sense making of complex artifacts is often a kind of highly personalized and often like analog process. And I think that like one of the things that's really important to keep in mind in the development of these tools are places where we want to keep those analog components that are like highly personalized. That perhaps it's hard to beat people reasoning through code by drawing diagrams on their own. And maybe that's just a skill that we have to equip them for and have tools get out of the way. And so I guess maybe the edgy response to that question is, I think that there's some thinking to do about whether that's something that does benefit from tool support, or if that's something that we would most benefit from understanding really good existing processes for sense making and diagramming and trying to diffuse that knowledge to as many people as possible. And I think that's kind of a complementary approach that this type of work could take. If some of the tool-based approaches couldn't pan out.
Great. Thanks. Thank you very much. This has been great.
Thank you, Lisa, for your questions.
Andrew, I have a question. Thanks for this great presentation. I was curious about the longevity of some of these initiatives in terms of particularly considering the archival purposes of some of all this research, if you will. Just to give as an example, when I worked on my thesis, I wrote it in standard, text document, but I also wrote the entire thing in HyperCard. So it has embedded animations, computational things on the page. You can click on things and so forth. Now that document cannot be opened anymore in HyperCard. You have to seek for the old technology, which doesn't exist anymore, to be able to open it. So it's pretty much vanished, and the only archival piece that is left is the written document. In fact, the one that you shared today, the DVD that Don Norman put together, cannot be opened anymore, as you might aware. And I actually had the original one, and it's just sitting in the library, just collecting dust. So I was wondering, with all these things that you are putting together and some, what do you think can be done potentially that these things become somewhat persistent and permanent? I had a chance to work with the Acrobat team, and quite a few decades now they've been around, and they are still having a hard time to integrate these type of things. So do you think that some of this stuff, especially research papers, can be opened 50 years from now with all these integrated things?
50 years from now is a really long time.
10 years, 20 years.
10 years, 20 years. So the prototype taken for the prototypes that we've built so far is that when it comes time for paper publication, essentially we make a JavaScript version that we try to make as future-proof as possible. And so what that usually means is that, like, for instance, the Scholarify application, when we developed the initial prototype, it relied on a backend server. But for the interactive prototype to live on in perpetuity, we mocked out that backend server. We essentially pasted all of the response JSON into that same application. We picked a single paper that we wanted to be able to demonstrate the interactions on, and then we compiled that to a single JavaScript example. And so as long as the web is continuing to run JavaScript and doesn't deprecate, and fingers crossed, doesn't deprecate some major APIs, it should hopefully continue to run. We did the same thing with Code Scoop and took some efforts to move in that direction with the code gathering tools project as well. And so this is something I've thought about, and our approach to date has just been try to boil this down to a single JavaScript and HTML application, file application that hopefully will be as future-proof as possible in our current ecosystems. Are we still going to be opening up applications in JavaScript and HTML another 20 years from now, another 50 years from now? I'm not really sure. And I guess that's the place where videos come into play. Are we still going to be using the same video formats in 50 years? I'm not so sure. So that's where, at that point, I'm kind of banking on the Wayback Machine and the Internet Archive to be able to, pick up these formats and hopefully convert them so we can continue to carry it forward. But, I think my own approach, my own perspective on this is that, that's why you have these complementary artifacts. If you have the demo, which is hopefully resilient, you have the video, which is hopefully even more resilient, then you have the PDF, which is hopefully, the most resilient of all. And you try to cram as much information about what it really feels like to use it into each one so that, at least so that you can really try to give someone a sense of what it is to play with these across those media. So I don't know what future media would look like that would be more future-proof, but I think it's a really interesting conversation and one I'd be happy to continue having with you.
Thank you. Nancy, you're in mute.
Thank you, Al. Anybody else want to speak up or?
Yeah.
Michael.
Well, yeah, well, thank you. Thanks for a very, interesting and inspiring talk. I guess, my question, so I'm a software engineer, but I work with a lot of computational biologists. So they're using our notebooks and they're producing, very complex code. They're using, various state-of-the-art packages they get from academics. But the problem is that the code is not very good because they're not software engineers. There's a lot of, it's messy. There's a lot of mistakes. And I'm actually, I find so many mistakes in the way these people work that I think it's actually a serious problem for science. You could probably go to any paper with computational results in it and find, and if you went and analyzed that, you'd probably find some errors. So the question, and I don't think this is directly relevant to what you're talking about, but it's kind of related, is how can we design IDEs for these kind of power users that can make their jobs easier and lessen some of the the messiness and error proneness of notebooks.
Yeah, absolutely. So I think that there's a real need here. So I think that when you look at data analysis practice within a computational notebook, I think that there's all kinds of types of messes that arise in it that don't arise in conventional programming settings, or I guess non-data analysis programming settings like you alluded to. And so I think that there's a lot more work that could be done on watching people produce these notebooks and trying to categorize some of the issues that they run into and trying to come up with some novel programming environment solutions that are specific to that group of users rather than something that's supposed to be general. And so, here's something that I've been thinking about recently. So one of the sources of messes within a computational notebook for a data analyst is just naming things. So over the course of an analysis, you might have a data frame, then in pandas, essentially a data table, and then it undergoes a series of different transformations over the course of a computational notebook. You might end up producing dozens of different variants of this one table as you clean it, as you reshape it, as you transform some of these columns. And at some point, you just run out of meaningful names because you already called something df, you called something df_cleaned for data frame cleaned, you call it df_cleaned_transformed, and so on and so forth. And so it ends up becoming really just difficult to remember the data objects that you're dealing with in a way that's not difficult in a conventional, I don't mean to say conventional, but in perhaps if you're programming a server or something, naming might not be quite as difficult because most of your variables might correspond to like a known abstraction that we have a good vocabulary
Sure.
for. So all that to say, I think that's like one of the pain points that like comes up when you've tried to do some of this programming, when you've also tried to watch someone do some of this programming. And I think it conveys to me that like maybe we need better ways of naming variables or representing variable names. Maybe you could add like iconography next to a variable name that describes what that what transformations that data frame has been under. Maybe you can make it a lot easier to preview some of the data and how it compares to some of the other data frames within a computational notebook. And so to take a step back, I think that we just need to watch people who are using computational notebooks for data analysis really closely and see where see what seem to be the causes of this underlying friction. And I think we could reveal a lot of these opportunities as invisible as like variable naming, that if you could solve them, you would come up with these other paradigms of programming that I think would suit people really a lot better.
Thanks. Yeah, no, I agree. And I just say, these are the people who really need IDEs or some kind of power tool to help them. So those are good ideas. Thanks.
Cool. Thank you.
Well, we've exceeded our time, and that was delightful. I'm glad everybody got a chance to chat with you, Andrew. And thank you for coming to BayChi. And is there anybody else who has a burning question that you can't wait to, and you want to share it with the rest of us, as well as Andrew? Last chance.
A quick thing, just a quick question. Andrew, does the notebook in VS Code, can it run on Google Colab GPU environment and from VS Code? And second one, if we have time, what are your thoughts on Swift Playground? Because I found that as a really awesome tool for learning or teaching coding to kids.
Yeah, that's awesome. So I'm not sure about the Colab integration. My guess is that it's not, because I think that the gather feature is currently unique to the Microsoft Visual Studio Code platform. And so if there's not an integration between the two of those, then I think that feature would not be available. My guess is that that's probably not present, but maybe I could be surprised as to the available integrations. For the Swift Playgrounds, I think that's a really great point. I've talked to some folks from Apple who work on some of those playgrounds and relevant tutorial documentation, and they're super passionate about this space and being able to author these documents better. And I think one of the things that I find really interesting about the Swift Playgrounds is that it not only continues in this tradition of like literate programming, of having these places where you can explain code right alongside that code, but it also continues in a tradition of live programming, which is allowing people to tinker around with that code and see the updates live. So I think from what I've learned, the Swift UI Playground has incorporated a lot of really interesting ideas, and it's great to hear that it's providing support for people like you in order to learn the tools. So I think that's about the extent of the commentary that I can give on it. But if there's anything that you'd like to share about your experience, perhaps that's something that we could do offline or at a later time, because I'm certainly interested in learning more about it, and I think it holds a lot of promise.
Thank you, everybody, for your participation. And thank you, Andrew, for staying up past midnight your time for us. BayChi appreciates it. We'll let you go now. And everybody, next month, we're going to get together again. And the old calendar on the wall says the second Tuesday is the 13th of September. And I believe our speaker is going to be a former BayChi program co-chair, Christian Crumlish, who has a book out about UX to product manager. And so he's going to talk about some of the role issues and the capabilities that UX people might have as product managers. Okay, enough for tonight. Thank you, everybody, and we'll see you next month. Bye.
Thank you so much, Nancy. Good to see you all.
Thank you, Andrew.